Hi all, welcome to my YouTube channel, Know About Embedded System. So in today's video, we will discuss one important topic that's called as a structure padding in C programming. So this is also one of the interview question, and in the most of the interview, this question appeared. So before starting the video, so if you're a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video, structure padding in C programming. The question will be appearing like this. So what is a structure padding in C programming and how we can avoid structure padding? So this is the question, like I told you already. So most of the interview, this question has appeared. So now we'll understand what is the definition of a structure padding. In C programming, structure padding means a technique where the compiler will add extra bytes to the structure member in order to align a memory properly. So what do you mean by structure padding? Structure padding means it's a technique where compiler will add or it will insert an empty bytes between the structure members to ensure that the memory is aligned properly. So what do you mean by this? Let us see with one example. Let us understand the structure padding with one example. Let us consider here I have one structure which by the name called as example, and which is having three members, which is a character and which is a integer type and which is a character. So we have three members here: character, integer, and again a character. So in this case, for in a general way, how many bytes the character will take? Character will take only 1 byte, integer will take 4 bytes, and character also will take only 1 byte. So according to the theory, this structure size supposed to be 6 bytes, 4 plus 1 plus 1. But in practical, because of this structure padding, so what the compiler will do? Compiler will add 3 additional bytes to the character and 3 more additional bytes to the second character as well. So this is called as structure padding. So why it is so? It is based on the compiler design and architectural design. So always your memory it's going to, a compiler will allocate always memory with the multiples of 4, like 0, 4, 8, 12, and it goes on like that. So in order to make sure the memory is aligned with multiples of 4, the compiler will allocate 4 bytes of memory for character and 4 bytes of memory for character, even though they are 1 byte. So how it looks like in the memory? So here you can see this is my memory and this is my character, which will take only 1 byte, but compiler will add 3 more bytes. This process is called as padding. So compiler will add 3 more bytes, or 3 more bytes the compiler will pad. That is called as a structure padding. And in a similar way, so integer, as you know that integer will take only 4 bytes straightforward, no problem with the integer here. Integer will take 4 bytes, but in the second scenario, the character, where the second character is defined here, this is also same case. It will occupy only 1 byte, but compiler will add 3 more bytes as a padding. Here you can say this is the variable C, and the compiler will add 3 more bytes. So in this way, so total size of structure, this defined structure will become 12 bytes instead of 6 byte. This is because of structure padding. So I hope you are clear with the definition of structure padding. Okay, so now why this structure padding will occur, that point we will understand. Already I told you the structure padding will occur because of a memory alignment. There are two major reasons are there. One is called memory alignment, and second thing is most of the processors will be working with a 32-bit architecture or 64-bit architecture, especially our modern CPUs. So modern CPUs will be working either in 32-bit or 64-bit architecture. If your processor is working on 32-bit architecture, it is going to fetch 4 bytes of data, and always the processors and compilers will align with the multiples of 4 memory location. Always memory deals with multiples of 4, or the processor will take, or it will fetch the data 4 bytes at a time. So typically 4 bytes or 32 bits at a time. So because of this, when you're dealing with a structure, the compiler will allocate 3 additional bytes whenever you're using character. Okay, so this is the reason. So I hope you understood what is the structure padding and why it will occur. Now, so how to minimize this structure padding? There are two major things we have to understand to minimize the structure padding. The scenario number one, where we can avoid or where we can minimize the structure padding. The structure padding can be minimized in a two different way. One way is we have to define the structure member which is having the most number of bytes first, like this. In this example, you can see here the structure integer b I'm assigning first, which will take 4 bytes as usual. And in the second step, I'm going to declare 2 character variables. So that means character A will take 1 byte and character C also will take 1 byte. And after that, compiler will add 2 more bytes. 2 more bytes the compiler will add. So in this scenario, if you calculate the size of the structure, the size of the structure will become now 8 bytes. 4 bytes for integer and 2 bytes allocated for character A and character C, and 2 additional bytes which are added as a structure padding. So this is a one way where the largest to smallest element or largest structure member to smallest structure member. This is a one way where we can avoid the structure padding. And we have one more way that is called as pragma. So this is one of the popular technique where we will be avoiding the structure padding in order to save the memory. So if you are using a microcontroller, which is having a very less memory, or if memory plays a very important role in your microcontroller, in that situation, so we have to avoid structure padding to avoid our structure padding. So in order to avoid this structure padding, we have to use the directive here, preprocessor directive called as hash pragma. By using hash pragma pack, so this is what we'll be using here, hash pragma pack. So this directive will tell to the compiler to avoid the structure padding, or you just pack the structure with 1 byte. So this instruction will tell to the compiler to pack the structure with a 1 byte. Right? So before structure definition or structure declaration, we have to use this assembler directive, preprocessor directive, hash pragma pack 1. 1 indicates the 1 byte alignment we have to go. So here you can see I have taken the example here. In this example, very straightforward definition. We're using example number 2. This is a one more structure. Again, similar to the previous structure only. Character A, integer B, character C. But important thing here is I'm going to use this time hash pragma pack. I'm using a hash pragma pack, and since I'm using hash pragma pack, if you observe here the structure, how the compiler is allocating a memory. So for character A specifically 1 byte, there will be no structure padding here, and again for integer B 4 bytes and character C 1 byte. And when you calculate the size of the structure here, the size of the structure will be 6 bytes, 1 plus 4 plus 1. So with the help of this assembler, this directive hash pragma pack, so with the help of this we can avoid structure padding. I hope you are clear. So now I have one use case, one simple program I have taken, and I have taken output here with hash pragma and without the hash pragma. So I have two functions here, or two structures here. The first structure without hash pragma and second structure with hash pragma, and both I have calculated size of the structure with the help of size of operator. So now you can see this is my first structure. So the one which I have taken previously, character A, integer B, character C, 1 plus 4 plus 1, but because of structure padding, 3 additional bytes will be added for first character, 3 more additional bytes will be added for second character, and the size of this structure will become 12. You can see the output here. The structure even is the first structure which is having the size of the structure is 12. So this is the first use case, and in the second use case, observe here, I have taken the second use case with hash pragma. Hash pragma pack 1 I have used, and same structure I'm using again, character ABC, and example number 2, 1 plus 4 plus 1, and the structure name is, structure data type is E2 here, and when I print it, now you can see the difference. The first structure will take 12 bytes and second structure will take 6 bytes. So this is how we can avoid structure padding with the help of hash pragma pack. Okay, so I hope this video is clear. So this is also very important thing for a embedded interview, especially the structure padding and how to avoid the structure padding. So I hope this video is clear. So if you feel this video is an informative video, please click on like button and subscribe my YouTube channel.